Archimedes, born around 287 BCE in the ancient Greek city of Syracuse, is one of history's most celebrated mathematicians, physicists, and inventors. His life and work had a profound impact on the fields of mathematics, physics, and engineering. Early life: Archimedes grew up in Syracuse, a Greek city-state in Sicily. Little is known about his early life, but he came from a well-educated family and likely received a comprehensive education in various subjects. Education in Alexandria: Archimedes traveled to Alexandria, Egypt, which was a renowned center of learning during his time. There, he studied under some of the most prominent scholars of his era, developing a strong foundation in mathematics and science. Mathematical achievements: Archimedes made significant contributions to geometry. He is best known for his work on the measurement of geometric shapes, including calculating the area of a circle and the volume of a sphere. His most famous discovery is the principle of buoyancy, known as Archimedes' principle, which states that an object submerged in a fluid experiences an upward force equal to the weight of the displaced fluid. Archimedes' screw: among his many inventions, the most famous is the Archimedes screw, a device for raising water. This screw-shaped machine is still used today in various forms for irrigation and drainage. Defense of Syracuse: during the Second Punic War, when Rome attacked Syracuse, Archimedes played a significant role in developing advanced military defenses for the city. He designed ingenious war machines, such as the Claw of Archimedes, which was used to lift enemy ships out of the water and drop them. His inventions delayed the Roman siege, but Syracuse eventually fell to the Roman forces in 212 BCE. Death of Archimedes: according to legend, Archimedes was killed by a Roman soldier while he was drawing mathematical diagrams in the sand, as he had been instructed not to kill him. His death marked the tragic end of a brilliant mind. Legacy: Archimedes' work in mathematics, physics, and engineering laid the foundation for many scientific advancements that followed. His contributions to the understanding of geometry and the principles of mechanics continue to influence modern science and engineering. The Archimedes principle remains a fundamental concept in the study of fluid dynamics and buoyancy. Rediscovery of his works: many of Archimedes' writings were lost to history, but some survived, including the method of mechanical theorems, which was discovered in the 20th century. This work revealed his innovative approach to solving mathematical problems and provided insights into his mathematical genius. Archimedes is celebrated as one of the greatest scientists of the ancient world, and his contributions continue to inspire and inform modern scientific thought and innovation. His legacy as a mathematician, physicist, and inventor endures as a testament to the power of human intellect and curiosity. Eureka! Moment: Archimedes is famously associated with the exclamation Eureka, meaning "I have found it," that he reportedly shouted while in the bath. The story goes that he was struggling to solve a problem related to King Hiero's crown, and the water displacement principle came to him as he saw the water rise while he immersed himself. This is often cited as the moment he made the critical connection that led to Archimedes' principle. Approximation of pi: Archimedes is also known for his work on approximating the value of pi. He accomplished this by inscribing and circumscribing polygons around a circle. By increasing the number of sides in these polygons, he was able to arrive at increasingly accurate approximations of pi, with the most famous being the 22/7 approximation, which is still used today. Quadrature of the parabola: Archimedes demonstrated that the area enclosed by a parabola and a straight line is 4/3 times the area of a certain inscribed triangle. This work on the quadrature of the parabola contributed significantly to the development of integral calculus many centuries later. Influence on modern science and engineering. Archimedes' work in mathematics and physics has had a profound and lasting impact on modern science and engineering. His principles of mechanics and the concept of leverage, as exemplified in the famous phrase, "Give me a lever long enough and a fulcrum on which to place it, and I shall move the world," continue to be fundamental in engineering and physics. Archimedean solids. Archimedes also studied and classified the so-called Archimedean solids, which are polyhedra with identical faces but different combinations of faces meeting at each vertex. This work laid the foundation for later developments in the study of polyhedra and geometry. Historical significance. Archimedes' contributions were highly significant during his lifetime and continued to influence mathematicians and scientists for centuries. His discoveries played a pivotal role in the development of mathematics and science during antiquity, and his methods and principles remain fundamental to various fields of study. Modern tributes. Archimedes' legacy is celebrated through numerous honors and recognitions in the modern era. His name is immortalized in the field of science through the naming of the Archimedes crater on the Moon and the Archimedes spiral, a mathematical curve. Archimedes' work transcended his time and place, leaving an indelible mark on the history of science and mathematics. His insights into geometry, physics, and engineering continue to inspire curiosity and innovation, serving as a testament to the power of the human intellect in understanding the natural world.